Yes. So we had done some calculations as well based on ionic product and solubility product. And in today's lecture, we'll discuss about the application of that solubility or the ionic product with respect to precipitation titration. Okay. So as per the definition is concerned, precipitation is nothing but the combination of two ionic species to form a very insoluble product. Okay, so whenever in a solution, if you have some number of ions and based on the number of those ions or concentration of those ions, when you multiply those concentrations and if the product is greater than its Ksp value, then they tend to form precipitate. Okay, and that precipitate will be insoluble product. Okay, so we'll study that mechanism and we'll use that mechanism in finding out the endpoint. So this particular principle, formation of insoluble product based on the combination of two ionic species, we can be able to estimate the compound provided that precipitation is complete at a point and that point can be determined. Okay, we can be able to utilize that concept of precipitation to find out the concentration of an unknown substance or unknown compound, provided whatever precipitation occurs, we can be able to detect that particular point. Okay, so to help us to detect the point at which precipitation occurs, we normally add any indicator. Okay, so અહીંયા બી જે બી indicator આપણે use કરશું, it has capacity to undergo the process of precipitation, and at the same time by forming the precipitation it will show us the color as well. Okay, so basically this precipitation titration are of two type. One is known as argentometric titration and second one is known as mercurometric titration. Only difference is what the titrant we use. Generally two titrants are used in precipitation titration. One is silver nitrate and other one is mercuric nitrate. If it is silver nitrate, then that titration is known as argentometric titration. If it is mercurometric titration, then the titrant will be mercuric nitrate. Okay. This also we discussed earlier, the difference between solubility product and ionic product. Now we'll see some factors that will affect the extent of precipitation. So you might have heard about these factors. Okay, can anyone explain what is common ion effect? What it can be? Yes.
It is a phenomenon in which when we add one ion which is in common to the two solutes, it causes precipitation and reduces the ionization.
Okay. Can you explain these particular phenomena with the use of some example?
Sir, if acetic acid is alone,
Okay, bolo, go ahead.
sir, if acetic acid is alone, then its acidity is higher. But when we add to it sodium acetate, then the concentration of acetate ion will increase. due to which the ionization of the acetic acid already present will decrease. So this is known as common ion effect. Due to the common ion present in both the solute, that is acetic acid and sodium acetate, the ionization of the acetic acid is decreased.
Okay. Anyone else who can describe common ion?
Sir, if we take example of acetic acid, and in acetic acid, if we add sodium acetate, then acetic acid will break down into H plus and CH3O minus, and acetic sodium acetate will break down into sodium and acetate. But as acetic acid is a very weak acid, so it won't dissociate much, and CH3COO would be much easily breakable. So it will break, and it will suppress, it will form acetate ion will again react with H of acetic acid, so it will suppress the breakdown of CH3COOH.
ઓકે, બીજું કોઈ અને બહુ ઇઝી વેમાં કોઈ એક્સપ્લેન કરી શકતું હોય તો, because I think these particular phenomena you have studied in your farm analysis as well by Rasmin sir. Okay, so you should explain it, or you're supposed to explain it.
Sir, in simple words, it may be that the effect which suppresses the ionization of electrolyte when another electrolyte which contains the same ion in the first electrolyte is added.
Okay, see, if you can recall the what you call yes, the standardization of NaOH. Okay, what was it? If you can recall the principle of standardization of NaOH, then
Sir, KHP reacts with NaOH.
okay, KHP reacts with NaOH. Fine. So in conical flask, we used the solution of KHP. Yes. Along with it, we used phenolphthalein as well. Okay. So when you compare these two substances, KHP and phenolphthalein, what is the nature of KHP and phenolphthalein?
Acidic.
Yes,
Acidic.
both are acidic. Both are acidic. Okay. And generally phenolphthalein or indicator ની વાત કરીએ તો all these indicators are weak acids or weak bases. બરાબર છે? Yes or
Yes,
no?
sir.
Yes.
Okay. So
Yes, sir.
that's true કે phenolphthalein ની આપણે વાત કરીએ તો it is obviously weak acid in nature. But in the case of KHP, it is little bit stronger than what you call the phenolphthalein. Okay, if you compare the acidity of both these substances, you will find KHP is stronger than phenolphthalein. Okay, now just imagine a conical flask is there. In that, KHP is also there, and what you call this phenolphthalein is also there. When you add any alkaline solution, NaOH, say for example, so that hydroxyl ion, whatever we are adding with the help of NaOH solution, this is supposed to react with both. જે બી એસિડ હોય એની સાથે રિએક્ટ થવું જોઈએ ને, બટ એ KHP ની સાથે જઈને જ રિએક્ટ કરે છે ઇનિશિયલી. જ્યાં સુધી KHP હશે ત્યાં સુધી એ KHP સાથે જ રિએક્ટ કરશે, ફિનોક્સિલિન સાથે રિએક્ટ કરશે નહીં. Why that so? That is the principle behind standardization of NaOH.
Because phenolphthalein is weak acid.
Yes, it's if you compare the strength, it is weak in nature. So ultimately એનું જે concentration છે ને અથવા એનું જે nature છે એ suppress થઈ જશે because of the strong acid present in that conical flask. So that is known as, so that's because of the ions generated by KHP as well as phenolphthalein. Okay, and those ions are common in nature, but only difference is their strength. Okay, so likewise, હવે તમે લાસ્ટ ટાઈમ જે આપણે NaCl ની વાત કરી હતી એનું થોડું જોઈ લો. NaCl અને HCl. When you have a solution of NaCl in water, NaCl dissolves in water. Dissolved ફોર્મમાં હોય અને એની અંદર આપણે HCl નાખીએ તો શું થતું હતું? HCl નું સોલ્યુશન નાખતા હતા તો લાસ્ટ ટાઈમનું જે આપણે એક્ઝામ્પલ લીધું.
Precipitation થતું હતું.
Okay, why? So that precipitation is nothing but formation of insoluble product as per the definition of precipitation. What was that? It is the formation of insoluble product. So by adding HCl, there is precipitation of NaCl. એવું કહી શકાય. એ બેની વચ્ચે કોમન શું છે HCl અને NaCl માં? ક્લોરાઇડ આયન? Yes or no?
Yes, sir. Yes,
Okay.
sir.
Yes, sir.
Yes, sir.
So addition of such ions which are common, that leads to decreased solubility of any slightly soluble salt. So if we talk about NaCl કે જે waterમાં soluble form માં હતું, by addition of HCl it provides the common ion, and because of that there is a decrease in its solubility. Precipitation થવું એટલે એની solubility ને reverse process થઈ કહેવાય. Okay, so such kind of factors can affect the extent of precipitation as well. When you have a solution of substance A, and if you add any substance કે એની અંદર common ion હોય કે જે already solution form A માં હતા એવા જો ions એની પાસે બી હોય અને તમે જો એમાં dissolve કરવાનો try કરો, then there is chances of decreased solubility of that particular ion, and that will affect the extent of precipitation as well. So that is the factor number 1, common ion effect, that will affect the extent of precipitation. Second one is effect of pH. Obviously pH in certain cases decreases the solubility of many of the weak acids or the electrolytes. Then we have effect of temperature as well, because precipitation જે વાત કરી મેં તમને કે precipitation is the reverse process to solubilization, and solubility is ultimately dependent on temperature. એટલે આપણે temperature વધારીશું તો you will find there is increase in solubility. એટલે precipitation નો extent જે છે એ ઓછું થશે if we increase the temperature. And fourth factor is addition of solvent. So if you add more solvents, obviously there is decrease in solubility, and you will find changes in the extent of precipitation. Okay, so these are the 4 common factors that affect the extent of precipitation, and ultimately they will intervene while we are performing the practicals related to precipitation titration. So જ્યારે બી આપણે એવા પ્રેક્ટિકલ ટાઇટ્રેશનના પરફોર્મ કરતા હોય કે જેમાં પ્રેસિપિટેશન અકર થતું હોય તો આ 4 ફેક્ટરને ધ્યાનમાં રાખવાનું. Because of these 4 factors you will find different result as well. Okay, so now in simple terms, if we describe the principle of precipitation titration, then it can be like this: a titrant that is to be filled in your burette. શું હોઈ શકે titrantમાં in the case of precipitation titration?
Silver nitrate
Mercury
and
and silver
mercuric nitrate.
Yes, એમાંથી કોઈ બી એક હોઈ શકે. બરાબર છે? So they can be called as precipitating agent as well. અથવા precipitating reagent भी કહી શકાય એને. So they are filled in burette in a conical flask. You will have your analyte that will be in solution form કે જેનું આયોનાઇઝેશન થયેલું હશે અને એ કેટલા ions present છે એ આપણે ચેક કરવાનું છે. That is our main aim. So your analyte will be present in ionic form and will add some indicator into it that is also having capacity to get ionized. So we'll use these three particular terms or these three particular system in the case of precipitation titration. You will require titrant filled in burette. You will require your analyte કે જેનું આપણે estimation કરવાનું છે and that should undergo the process of ionization. At the same time we require indicator એની બી capacity હોવી જોઈએ to get ionized. Okay. So initially when you add your titrant into conical flask containing your analyte and indicator, what will happen is this titrant will react with your analyte first. Again same અહીંયા જ વસ્તુ છે depending on their strength. So it will react first with your analyte and there may be chances of precipitation. પણ એ precipitation થતું છે ને આપણને દેખાશે નહીં, કાં તો દેખાતો બી હશે બટ કલર ચેન્જ નહીં થાય. સો જ્યાં સુધી એનાલાઇટ જેટલો બી પ્રેઝન્ટ છે એની સાથે ટાઇટ્રન્ટ જે બી આપણે નાખશું એનું રિએક્શન થશે. જેવું એનાલાઇટ જે કોનિકલ ફ્લાસ્કમાં આપણે લીધું છે એ ખતમ થઈ જશે એટલે એક્સ્ટ્રા એડિશન ઓફ ટાઇટ્રન્ટ will react with indicator then. એટલે પછી એ ઇન્ડિકેટર સાથે ટાઇટ્રેશન કરશે અને ઇન્ડિકેટરની સાથે એ પ્રેસિપિટેટ કરશે. જેવું એ એનું પ્રેસિપિટેશન ઇન્ડિકેટર સાથે થશે it will show us the color change. So what does it indicate when there is color change? What will be our inference?
The titrant has started reacting with indicator and analyte is over.
Yes, that shows the reaction between titrant and analyte gets over. Or analyte નું concentration હવે બચ્યું નથી એટલે એ જે burette reading આવ્યું છે જ્યાંથી કલર ચેન્જ આવે છે that shows our end point. So it is simple acid base titration જેવું જ છે but the mechanism will be formation of precipitate. Okay, so at the end no analyte will be there. So when you add your titrant it will react with indicator ion and you will find colored precipitate. That will be our end point. So this is a common principle followed in precipitation titration. If you have any doubt you can ask because આ જે પ્રિન્સિપલ છે એ બધા જ ટાઇટ્રેશન જેટલા બી પ્રેસિપિટેશન ટાઇટ્રેશન છે એના માટે કોમન રહેશે. Yes. Okay, so now we shall see its application part કે ક્યાં use થાય છે, precipitation કેવી રીતે થાય છે actually. Okay, so when we are talking about precipitation titration it is categorized in 3 different types of titration. Let us see the first one that is known as Morse method. So Moore's method, okay, so that involves a direct titration with the formation of colored precipitate. જે આપણે initially તમને principle સમજાયો, that is typical example of Moore's method, and by this way we can determine chloride ion or bromide ions specifically in neutral or slightly alkaline pH. So but specifically it is not used for determination of iodine. Okay, so we shall see the procedure first કે એ કેવી રીતના યુઝ થશે, તો you will get the better idea about Moore's method. Okay, so it will be like this. Suppose you want to estimate the chloride ion, then you will take or you will prepare primary standard solution like NaCl, that is to be taken in 25 ml water. એટલે 0.2 ગ્રામ તમારે NaCl dissolve કરવાનું છે 25 ml water માં. So it will be a colorless solution. Okay, then in that we are going to use some indicator. So in this particular case it will be 1 ml potassium dichromate 5% weight by volume. So this will be our indicator K2Cr2O7. So at this point of time in a conical flask you will find 25 ml NaCl solution containing 0.2 gram of NaCl. Along with it, it has potassium dichromate as an indicator as well. Now next step would be we'll titrate it against our titrant, that is obviously silver nitrate solution. So કેટલું બનાવવાનું છે? In this particular case we prepared it like 0.1 molar. So in a simple way જે રીતના આપણે molar solutions બનાવીએ છીએ, likewise we have to prepare it. So the molecular weight of silver nitrate is 169.9. So you can take 170 gram as well. Okay, so in a simple way 1 molar માટે 1000 ml હોય તો 170 gram. Likewise 100 ml 0.1 molar માટે 1.7 gram silver nitrate is needed. Okay, so એટલું solution આપણે બનાવીને પછી we'll take it in a burette and then we'll start titrating it with the content present in our conical flask. So what will happen when you add AgNO3 into our conical flask? જેની અંદર શું છે? NaCl and K2Cr2O7. Okay, so this NaCl will get react by silver nitrate, and after a certain time જેટલું બી NaCl છે, okay, એ શું થશે? AgNO3 plus NaCl નું reaction થશે and there is a formation of AgCl, precipitate form થશે AgCl in a conical flask. Okay, so it will be like this. તમને જે white color દેખાઈ રહ્યો છે ને conical flask માં, એવા precipitate હશે. When we start titrating our NaCl solution containing indicator with AgNO3. And it will, because of this it will form precipitate of AgCl. So when no more NaCl is present કે જ્યારે જેટલું બી NaCl છે, because we have taken it in a fixed quantity, કે બધું જ NaCl જ્યારે યુઝ થઈ જશે with AgNO3, when there is no more NaCl present in conical flask, extra drop of AgNO3 will react with કોની સાથે react કરશે?
Potassium dichromate.
Potassium dichromate.
ઓકે, અને જેવું એ પોટેશિયમ ડાયક્રોમેટ સાથે રિએક્ટ કરશે એનો કલર ચેન્જ થઈ જશે લાઈક ધીસ, ઓરેન્જ કલરના પ્રેસિપિટેટ દેખાવાનું સ્ટાર્ટ કરશે. So when there is color change from this off-white precipitate to orange precipitate, that will be our end point. We have to take down the burette reading at this point of time, and then we'll do some calculations so that we can be able to find out the concentration of chloride ion or ultimately the concentration of NaCl we have taken. So for that we need to derive the factor. So the reaction will be like this: AgNO3 react with NaCl, it will form the precipitate of silver chloride. When there is no NaCl, two molecules of silver nitrate react with one molecule of K2Cr2. Okay, અહીંયા થોડું મિસ્ટેક છે. ઓકે, પોટેશિયમ ડાયક્રોમેટ બી લઈ શકો તમે, પોટેશિયમ ક્રોમેટ બી લઈ શકો. That won't be a problem. Okay, so it will react with the indicator and will form the resultant orange colored precipitate of the complex of silver with K2Cr2 O7 or K2Cr O4. But our main concern is the reaction number 1. What does it mean? It will find us 1 mole of AgNO3 is equivalent to 1 mole of NaCl. So in this particular case, primary standard क्यों હતું?
NaCl.
NaCl.
Okay, so એને આપણે ગ્રામ્સમાં કન્વર્ટ કરશું, એને આપણે ગ્રામ્સમાં કન્વર્ટ કરશું, અને જે સેકન્ડરી સ્ટાન્ડર્ડ છે સિલ્વર નાઇટ્રેટ એને આપણે વોલ્યુમ્સમાં લઈશું. So it will be like this: 1000 ml 1 molar AgNO3 is equivalent to, મોલને ગ્રામમાં કન્વર્ટ કરવું હોય તો એના મોલિક્યુલર વેટ સાથે મલ્ટીપ્લાય કરવાનું. So it is 58.4 gram NaCl. So for it is for 1000 ml, for 1 ml 0.1 molar silver nitrate, it will be like, and the cross multiply करसो, so you will get the answer 0.00584 gram NaCl. Okay, so based on that you have to find out the concentration. કેવી રીતના આના ઉપરથી કેલ્ક્યુલેશન કેવી રીતના કરી શકાય ફર્ધર, કોઈ કહેશે મને?
Sir, for like each 1 ml of 0.1.
બોલો બોલો, 1 by 1, વાંધો નહીં.
Sir, we can take X molar, X ml, Y molar AgNO3 it will be equivalent to the previous grams of NaCl we taken. So we can write it like that and then find the molarity.
I want the final equation for Y molar, what it can be.
Y is equal to 0.1 into 1, 0.1 molar into 1 molar, nahin, 1 ml into 0.1 molar.
Just do it in your notebook and then disclose it. Yes.
Sir, shall I?
Yeah, please.
X molar will be equals to 0.2 gram into 1 ml into 0.1 molar divided by 0.00584 grams into y ml. That is butyrated.
That's perfect. Okay. So in this particular case, Y molar will be X molar તમે લખી શકો કાં તો Y molar લખી શકો, but પાછળ unit લખવાનું ખાસ. So Y molar, that is the actual molarity of silver nitrate, that will be equal to 1 ml into 0.1 molar into 0.2 gram divided by butyrating multiply with 0.00584 gram. So this will be our equation to find out actual molarity of silver nitrate, and that is nothing but standardization of silver nitrate solution. Okay, so by this way we can standardize silver nitrate solution as well. At the same time we can perform or we can determine the concentration of NaCl as well. Actual NaCl આમાં ન પડતી તમને આઈડિયા આવી જાય. Okay, so that will be the second part. આપણે application જ્યારે કરશું ત્યારે જોઈશું, but that this is okay about the modes method. Okay, so modes method is nothing but, so here what is happening is there is direct titration. જે બી એનાલાઇટ છે, એનાલાઇટ શું હતો આપણો NaCl, એને આપણે કોનિકલ ફ્લાસ્કમાં લીધો છે, અને જે ટાઇટ્રન્ટ છે AgNO3 એનું NaCl ની સાથે ડાયરેક્ટ titration થાય છે, and it will form a colored precipitate. That is the principle of Moore's method. And આ ટાઈપનું જે પ્રિન્સિપલ છે can be used for determination of chloride ion and bromide ions, specifically in neutral pH or slightly alkaline pH. કેમ એ pH mention કરી છે, that we can see in further slides. Okay. So આ જે રીતના આપણે તમને પ્રોસિજર સમજાવી એ જ છે, અને અહીંયા you'll find the formation of precipitate as well. Yes, this is important and interesting. Limitation of Moore's method. So as we have mentioned earlier, its limitation is it can be carried out at neutral pH or slightly alkaline pH. કે જે ક્લોરાઇડ આયનનો એસ્ટિમેશન છે અથવા તો bromide ion estimation છે, that can be performed at neutral or slightly alkaline pH between 6 to 10. So what will happen at acidic pH or acidic media? So in acidic media what happen is chromate ions જે આપણે લીધા છે because of the indicator, they will react with the H plus ion. Acidic medium માં H plus ion હશે અને એની સાથે chromate ion react કરશે and it will form HCrO4, which is only slightly ionized, એટલે further એનું ionization થશે નહીં. So એ અલ્ટિમેટલી શું કરી રહ્યો છે? Thus it decreases the concentration of chromate ion. હવે તમે વિચારો કે ક્રોમેટ આયનનું કોન્સન્ટ્રેશન ઓછું થઈ જાય, so that means ઇન્ડિકેટરનું કોન્સન્ટ્રેશન ઓછું થાય તો it won't show us the exact end point, કે એનું રિએક્શન પછી સિલ્વર નાઇટ્રેટ સાથે થશે જ નહીં. Are you getting it?
Yes, sir.
Okay, so that is why acidic media is avoided. Likewise, in alkaline medium, what happens is, in alkaline medium you will find more hydroxyl ion. So because of the more hydroxyl ion, જેવું તમે silver nitrate add કરશો, it will form AgOH twice, and એના precipitate તમને દેખાશે, which is not required. ઓકે, આપણે ક્લોરાઇડ આયન એસ્ટિમેટ કરવાનું છે એટલે AgCl ના precipitate બનવા જોઈએ, but in place of AgCl, AgOH twice ના precipitate થાય છે in alkaline medium. Okay, and that is why these media are avoided when we are going for Moore's method. So that is the limitation of Moore's method. As we have discussed earlier, it can be used for determination of chloride ion or bromide ion, but it is not used for iodine ions, or it is not applicable for finding out the concentration of iodide ions. Okay, iodine જે છે એના ions આપણે શોધી ના શકીએ, and at the same time thiocyanate na ions we cannot determine by this particular method. Why? Because when you add silver nitrate into iodine solution or into the thiocyanate solution, it will form AgI as well as Ag thiocyanate, so respectively, and both adsorb, આ બે જે કોમ્પ્લેક્સ બની રહ્યો છે AgI અને AgCN, it has capacity to adsorb, સ્પેલિંગ જોઈ લો, adsorb chromate ion. adsorb કરવું એટલે
It gets sticked, or I can say placed on the surface. It does not react
yes,
with that.
yes, there is a vast difference between absorb and adsorb. absorb થવું એટલે અંદર લઈ લેવું, અને adsorb એટલે શું થાય, just like તમે પેલું મેગ્નેટ જોયું છે ને, મેગ્નેટ તમે જ્યારે ખીલી પડી હોય, બે ત્રણ ખીલી પડી હોય એની પર નજીક લઈ જાય તો શું થાય, જે બી કીલ્સ જે છે એ સ્ટિક થઈ જશે મેગ્નેટની ઉપર. that is known as the process of adsorption, એટલે સરફેસની ઉપર સ્ટિક થઈ જાય. સો અલ્ટિમેટલી આ બી શું કરી રહ્યું છે, ક્રોમેટ આયનનું કોન્સન્ટ્રેશન ડિસ્ટર્બ કરી રહ્યું છે, and that gives us false result. એટલે ક્રોમેટ આયન ફર્ધર કોઈ એનું રિએક્શન થશે નહીં with silver. So આ જે ત્રણ કન્ડિશન છે that will hinders the actual titration when we are talking about Moore's method, and that is why they are not performed in acidic condition, alkaline condition, and not applicable to iodine as well as thiocyanate ions. And the fourth limitation is it is only applicable to room temperature. See, almost all the precipitation titration, they are applicable at room temperature only. Why? Because as you change the temperature, or as there is changes in temperature, solubility of any precipitate gets changed. That is why it is to be applicable at room temperature only. So these are the four limitations of Moore's method. So if you have any doubt, you can ask related to precipitation titration. Okay, So we are concluding our lecture at this point of time. In next lecture, we will see different type of precipitation titration. આજે આપણે મોર્સ મેથડની વાત કરી છે. In the next method or in next lecture, we will talk about Volhart's method and Fajan's method. These are the two methods, or total three methods are there in precipitation titration. First one is Morse method, જે આપણે ડિસ્કસ કરી હમણાં જ. Second one is Volhart's method, and third one is Fajan's method. Okay, which are the three applications of precipitation titration, and all three methods have different sort of mechanisms. Okay, so that's it for today's lecture. We can discuss the further part in our next lecture. If you have any doubt further, we can discuss right now. કઈ બી issue હોય